Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2026-0406. Okay, so today we are diving into a paper that tackles a very specific but super important problem, teaching AI to actually understand charts and graphs. You know, those bar charts in reports or line graphs in articles. For us humans, it is kind of easy. We see the bars, read the labels, and answer a question. But for AI, this is surprisingly hard.
That is exactly right, Isabel. This task is called Chart Question Answering, or CQA, and it is a major bottleneck for current vision language models. The issue is not just reading the text on the chart, but performing true visual reasoning. The model needs to extract precise numbers, understand spatial relationships, like which bar is taller, and then logically infer an answer. Most models today are better at pattern recognition than this kind of integrated reasoning.
And the consequences are very real. If a model cannot accurately read a simple bar chart, how can we trust it with more complex data analysis? The current methods often fail at precise numerical extraction, and they struggle with implicit relationships. For example, if a chart shows sales over time, and you ask for the quarter with the highest growth, the model needs to calculate differences, not just find the tallest bar. Most models miss that step.
So the paper we are discussing introduces a solution called ChartRL. JJ, can you break down what RL is here, and why it is better than just more training data?
Certainly, think of reinforcement learning not as studying from a textbook, but as learning by doing with a coach. Instead of just showing the model millions of charts and correct answers, we put the model in a practice environment. Every time it tries to answer a chart question, it gets feedback, a reward or a penalty, based on how close its answer was. This feedback loop allows the model to optimize its own internal policy. Its strategy for looking at the chart and reasoning through the problem. It learns which visual features to pay attention to, and how to chain logical steps together to reach the correct answer.
The key innovation is the design of this feedback system, the reward function. The researchers did not just give a reward for the final answer being right or wrong. They created adaptive rewards for intermediate steps. Was the numerical value extracted correctly? Did the model attend to the right part of the chart? This guides the model much more effectively towards robust reasoning, not just memorizing answers.
That sounds powerful, but also computationally expensive. Training giant AI models with RL is not that usually need a huge server farm.
That is the other clever part. They used a technique called parameter-efficient fine-tuning, specifically LoRa, instead of retraining the entire massive model. LoRa adds tiny, trainable adapters to the existing model. It is like giving the model a new set of specialized tools without rebuilding its entire brain. This means they could do this advanced RL training on a single GPU, which is a huge deal for accessibility.
And the results were impressive. They took a model called QN3VL with 4 billion parameters, and after ChartRL training, it outperformed its own bigger brother, the 8 billion parameter version. The smaller, optimized model achieved higher accuracy, and it was dramatically faster, reducing answer time from 31 seconds down to 9 seconds.
Wow, so they made it smarter and faster, with fewer resources. That is a win-win-win. But Jiyoung, you always have the critical lens. What are the limitations or the bigger picture implications here?
The framework is promising, but it is still evaluated on a specific dataset. Chart QA Pro, real-world charts are messy, with inconsistent formats, bad color choices, or even misleading scales. The next challenge is generalization. Also, while this improves reasoning on a given chart, it does not address the model's ability to critique the chart itself, to point out if a visualization is deceptive. That is a crucial skill for true data literacy.
I agree. This is a significant step toward more reliable and efficient visual reasoning agents. It shows that with clever training methodologies, we can extract much more capability from existing model architectures. The combination of RL for strategic learning and LoRa for efficiency could be a blueprint for enhancing other multimodal tasks beyond charts.
So to wrap up, ChartRL is like giving an AI a personal tutor for reading graphs, using targeted feedback to build better reasoning skills, all in a cost-effective way. It is a smart push towards AI that does not just see, but truly comprehends. Thank you everyone for joining this deep dive.
Thank you.
Thank you.